So this is the test bench for my force feedback system. The electronics, the software, and the design concept come from a gentleman in the UK, Ian. Has his own business called Built for Fun Electric Vehicles, and he's been great to work with. I am a fanatic about good quality products and exceptional customer service, and he meets both. So just to give you a quick description, what you're seeing is a chassis that I assembled. I bought a rack chassis and all the other peripheral hardware that goes with it. Ian's circuit cards are in there. 24 volt power supply. The system does run on 24 volts. What's in the middle here is really sort of bells and whistles extras. It's optical relays or solid state relays to run latching circuits so that I have a better control of the system. Not essential, certainly extras, but I like having it. I also used breakers rather than fuses on here, appropriately rated breakers to fuse the AC, the DC, and the 3 separate motor driver cards. In addition to that, there are status LEDs and a power meter and the switches that activate everything. So above that, again, in a test bench assembly, are the 3 motors that will eventually be built into linkages into the elevator and ailerons on the yoke and the rudder pedals. There's also an emergency disconnect switch that will go inside the cockpit and outside at the instructor station should anything happen to the system and require a panic stop. So let me walk through the startup and calibration procedure here, and then I'll show you a little bit about how it functions. So I'm going to activate the AC power. Now that the AC power is on and I can hear the cooling fan running for the power supply, I'm going to turn on the 24 volt DC bus, confirm that my power supply is working correctly and is producing the 24 volts, and then I'll activate the controller boards. When they activate, they go through a calibration startup sequence, and eventually these LEDs start to flash, indicating that they're waiting for a range test on the 3 control axes. So I'll start with the elevator axis, and I'll walk it from full range in either direction, back and forth, until it registers and tells me it's calibrated. As you'll see, the LED is in a normal blinking mode here, meaning it's calibrated. So I'll do the ailerons, and I can feel the motor actually start to apply resistance partway through that cycle, and then the rudder. And now all 3 are indicating that they're talking to the controller and ultimately to the software on the flight sim PC. So now you'll notice I can feel slight resistance on them, but they're not responding in any way because they're not talking to the computer yet. So the next thing I'll do is I'll reach up and in software, I'll activate the motors, and you'll see that the elevator immediately dropped down, which is what you'd expect in a real aircraft. In an aircraft that's not running, the weight of the elevator will pull the yoke in normally. You'll also notice slight movement, I don't know if you can pick that up in the video, in the ailerons, which is actually because there's heavy winds on the airfield right now, and they're actually jogging the aircraft a little bit. So it does pick up all of those various inputs. So now what I'm going to do is start the aircraft. You should hear it. I think you'll pick it up on the video running in the background. And again, I'm not sure it'll pick up on the video, but I can now feel vibration from the engine in the controls, okay? Now the other interesting thing is, and I've overemphasized it for the video, but on a lot of aircraft, depending on the size of the prop position versus the elevator, etc., and the amount of airflow it generates, you'll get some movement of the yoke back. The elevators will actually respond to prop wash if you have a high enough RPM. So I'm going to max out the engine, and you'll watch this axis pick up on its own. Again, this is a little overemphasized. So now you can see that the air movement over the elevator is actually moving it upward. And again, I've actually intentionally exaggerated that in the settings to demonstrate it. So that's how the force feedback system works. And again, you can see I can feel the vibration. I don't know if you're able to pick any of it up on the video from what it's doing to my hand, but I can feel the vibration from the engines and the airflow over the control surfaces in my hands. I can feel the spring sensation you get from the rudder pedals when the nose wheel is on the ground. And as soon as I put this in the air, these controls would smooth right out. So that's the nickel tour. Again, I can shut the system down by any one of a number of panic modes if I have to, the panic switch or kill the main power, or I can shut down the logic boards and reinitiate them to recalibrate them if I had to. So that's the grand tour. I think I'll do a separate video to show you how this interacts with the aircraft.